Thank you, Natalie. Well done. When we think of rational numbers, when multiplying, we're talking about decimals and fractions. Yes, no?
Yes.
All right. We know what a rational number is. We've talked about it a lot. It repeats, or it terminates, or it's an integer. It can be written as n over d as long as d is not what? Zero. And n and d represent what and what? N and d. N numerator, d denominator. You guys know what a product is? Multiplying fractions. This is a big one. We talked about cross-reducing. Do you have to cross-reduce when multiplying fractions? No. It is a really, really handy strategy to make your multiplication simpler. Right, Jake? But you don't have to do it. We gave you an example on A, 1/2 times 4/5. Cross-reducing is looking at opposite numerators and denominators. And if they have a common factor, like 2 and 4 has a common factor of 2, you can reduce those two numbers. Obviously, there would be no cross-reducing with a 1 and a 5. You don't necessarily have to do that, but you can. You guys know the rules. Mixed numbers must be converted to impropers when calculating, and then answers must be always converted back into mixed numbers when necessary. Number 5, you can see we multiplied 2 and 5 1/3, which really is 2 times 16/3 because we converted that 5 1/3 to an improper. Our final answer turned out to be 32/3. Is that your final answer? No. It needs to be converted back into a mixed number. Number 6 is another example of cross-reducing. Number 7, this is just a different way of showing that we're multiplying with the parentheses in there. Both were converted into impropers. Multiplying decimals. When multiplying a decimal, the answer always is what? Where's the decimal point in the answer when multiplying decimals? Someone explain that to us. Where is the decimal point in the answer when multiplying decimals? Where would it be? Where would it be, Danny?
If you have two decimals and your first one and then a decimal on your answer, you need to have 3 decimals because there are 3 decimals in the problem.
Okay. So we multiplied 2300 times 4/10, and the answer according to Haddon was 92 thousandths, right? His decimal point was in 3 spots from the end of the number. Because that decimal was in 2 and that decimal was in 1, what's 2 plus 1? 3. So how many ever your factors total, as far as the decimal point being moved in, should be the total for your answer. Does that make sense? Are we good? Okay. You can read through the true and falses on your own. You guys seem very, very confident in those. And then number 4, our word problem with Brandon and his Greek and Latin project wasn't necessarily the math that was the problem. It was answering the question that became the problem. Remember, on this one, a lot of us, I know a lot of you didn't admit to this, but a lot of you only did part of the problem. You just answered the question for how much of the Greek and Latin project he had finished, whereas it said how much will he have left to do. So you need to take that answer and subtract from one whole. Okay, so make sure you read the problems carefully and answer the question you're asking. Anything before I stop?